Okay, hey there guys. These are just going to be some problems that we don't change the process just because we have fractions or decimals. It's just things look a little bit messier, as they always do when you have fractions and decimals involved. So, you aren't really learning anything new. You're either A, doing calculator practice, or B, I'm going to show you a way to get rid of the fractions and decimals so that you're dealing with numbers that look a little bit cleaner. You do still come up with the same answers no matter which way you work the problem. So if you're happy using your calculator, then keep on doing that. Otherwise, maybe this will show you something pretty cool that can help you get rid of those things that are ugly. Okay, so take a look at this. 1/8 x plus 1/2 equals 1/4. Now, if this were just a problem like, let's say this. Then the first thing that we would do is we would subtract 3 from both sides, okay? And same thing goes with this. Just because they're fractions doesn't mean we change our process. We would subtract 1/2 from both sides. Okay, this right here creates 0, so that would go away. You're left with 1/8 x is equal to, now you would need a common denominator, so 1/4 minus 1/2 is the same thing as 1/4 minus 2/4, which is a negative 1/4. Now, what you could do is you could divide by 1/8, but dividing by 1/8 here is the same thing as multiplying by its reciprocal. So dividing by 1/8 is the same thing as multiplying by 8. And so this creates 1. We wanted to create 1 in front of x. And we know that a negative times a positive is a negative. And 4 will go into 8 twice. So our answer is x equals -2. Now, remember this. So remember, our answer is x equals -2. Okay, I'm going to circle that and leave that up there. So if you need to take a screenshot of this, take a screenshot of this, but I'm going to erase the work and I'm going to show you another way to work this problem. Okay, so another way to work the problem is take a look at those denominators, 8, 2, and 4. And if I had to create common denominators for all three of these fractions, what would that be? Well, the common denominator would be 8. So, if I multiply each and every term by 8, so that means I'm going to distribute 8 times everything. Let me show you what happens. 8 times 1/8, the 8s would cancel, and I'm just left with 1x or x. 8 times 1/2, so half of 8 is 4. 8 times 1/4 is the same thing as 2. Okay, so now look what just happened. We turned this nasty looking thing into something that isn't so nasty. So now, how do you solve that? Well, you would subtract 4 from both sides. And so I've got that x is equal to -2. Again, we get the same answer. Okay, so now can you still check your work? Absolutely. Still go back to the original problem though. So you would have 1/8 times -2 plus 1/2. Does that equal 1/4? So 1/8 times -2 is the same thing as -2 over 8. And I can make this, I could reduce the -2 over 8, or I could turn the 1/2 into something over 8. So I'm going to go ahead and turn that 1/2 into something over 8. -2/8 plus 4/8. Does that equal 1/4? -2 plus 4 is 2. Does that equal 1/4? Yep. Okay, so again, I don't really care which way you do it. If you keep it all as fractions, make sure that you're using your calculator or at least checking your work, and or you could turn it into for something from this to this. It's up to you. I'm just showing you another way to work the same problem. If you're comfortable with the way you've been working problems and you're doing well at it, then don't change that process. But I'm just showing you something else that works. Okay, so we have a lot of fractions in this problem as well. So if you want to just use your calculator and combine your like terms, you could. So on your calculator, you could type in 1/2. Don't put in the x, it's a bad idea. So just type in 1/2 plus 3/4 minus 2/3. And so whenever you do that, you wind up getting 7 is equal to 7/12 x. Okay, so then how do you solve for x? Well, divide both sides by 7/12. So type in on your calculator 7 divided by 7/12, and you get that 12 is equal to x. Okay, so again, this is one way to work the problem. I used my calculator, I combined my like terms, I didn't get rid of my fractions, I just used the calculator and let my tool work for me. So again, I'm going to write down the answer up here, and I'm going to erase the rest of this, and we're going to work it a different way just to show you that it is possible to get rid of those fractions. Okay, so if you wanted to get rid of the fractions, what would you do? You would look at 2, 4, and 3, and you would ask yourself, what is the lowest common denominator between 2, 4, and 3? So I usually start with my highest number. I know that 3 won't go into 4, but 2 will, but that doesn't help. They all need to be able to go into the same number. So what's my next multiple of 4? It's 8. Well, 2 will go into 8, but 3 won't. So let's go up to the next one. Next multiple of 4 is 12. 2 will go into 12, 4 will go into 12, 3 will go into 12. Okay, so my common denominator is 12. So watch this. I'm going to multiply each and every term by 12. 12 times 7 is, hang on. And then 12 times 1/2 x is 6x. 12 times 3/4 is 9x. 12 times 2/3, or negative 2/3, is negative 8x. So now it went from ugly to not so ugly. So now we can combine our like terms. So you get 84 is equal to 6x plus 9x is 15x. 15x minus 8x is 7x. And then divide both sides by 7. And you get that 12 is equal to x. And again, check your work. So you could do 7 is equal to 1/2 times 12 plus 3/4 times 12 minus 2/3 times 12. Half of 12 is 6. 3/4 times 12 is 9. 2/3 times 12, we've got a negative 8 there. So we hope that 7 is equal to, what's 6 plus 9? It's 15. 15 minus 8 is 7. So I know that this is my correct answer. Okay, so I'm not even going to show you both ways now. I'm just going to show you how to get rid of the fractions. Again, if you choose to not get rid of your fractions, but you still follow the correct processes that I've taught you, then you're going to be fine. But I just want to show you the other way is possible as well. So, what is the common denominator between 3, 6, and 2? It is 6. So I'm going to multiply each and every term by 6. So I get 6x. 6 times 1/3 is 2. 6 times 1/6 x is just x. 6x times a negative 1/2 is a negative 3. So now I've got variables on the left side and on the right side. So I want to move my smallest variable. That's my habit. I always move the smallest one. So I get 6x minus x is 5x, bringing this straight down. Bringing this straight down, that created 0. So now I'm going to subtract 2 from both sides. 5x is equal to negative 5. Divide by 5. And I get that x is equal to negative 1. So, check your work. So I've got negative 1 plus 1/3. Is that equal to 1/6 times negative 1 minus 1/2? So, negative 1 plus 1/3, I can write that as negative 3 over 3 plus 1/3. And this I can write as negative 1/6 minus, I'm going to change that into something over 6. And I'm going to see if I get the same answer. So negative 3 plus 1 is negative 2/3. Negative 1 minus 3 is negative 4/6. But once I reduce this, yep, so I know that's the correct answer. Okay, so there's several ways that you could work this problem. I'm going to tell you that you probably should distribute first, although that is not a total requirement. But since I'm not in class with you right now, I don't want to confuse you anymore. So let's go ahead and just distribute, and I'm going to show you that the fraction is going to go away anyway on its own. 1/2 times 4x is 2x. 1/2 times 2 is 1. So now that turned into something that is actually pretty easy to work with. So again, you want to move everything away from that variable. So I'm going to subtract 1. I get 0 is equal to 2x. Divide by 2. 0 divided by 2 is 0. So x is 0. You can check your work. That's a multiplication sign. 4 times 0 plus 2. So 1 is hopefully equal to 4 times 0 is 0. 0 plus 2 is 2. Half of 2 is 1. So x does equal 0. Okay, for this problem right here, there's several ways to work it, and as long as you're performing legal moves, then there's multiple ways that you could start this thing off. I'm going to recommend, because I feel like everybody is already in this habit of just distributing, go ahead and do that. Then I'm going to show you how to get rid of the fractions. So 1/2 times y, you get 1/2 y. 1/2 times negative 5, you get negative 5 halves. 1/4 y, you get 1/4 y. 1/4 times negative 1 is negative 1/4. So now take a look at what the common denominator is between the 2 and the 4. It's going to be 4, right? So if I multiply everything by 4, my fractions go away. 4 times 1/2 is 2. 4 times a negative 5 halves is a negative 10. Grab your calculator if that bugs you. 4 times 1/4 is 1, or just y. 4 times negative 1/4 is a negative 1. So now I want to get my y's on the same side, and I want to get my constant terms on the other. So subtract 1y. 2y minus 1y is just y. I'm bringing this straight down. That created 0. So I'm going to add 10 to both sides. Y is equal to 9. So let's test it. So I've got 1/2 times 9 minus 5. Is that equal to 1/4 times 9 minus 1? So I'm going to do 9 minus 5 and 9 minus 1 in this first step. 1/2 times 4. Is that equal to 1/4 times 8? Half of 4 is 2. 1/4 of 8 is also 2. So I know that this is the correct answer. Okay, so you might be asking yourself, well, how in the world do you get rid of a decimal? You can get rid of decimals the same way that you get rid of fractions. Only difference is you're going to be multiplying by a power of 10. So, and that power of 10 is determined by how many decimal places do you see in the problem. I see 1 decimal place at the most in this problem. So that means I'm going to multiply by a 1 with only 1 0 at the end. That number of zeros determines how many decimal places you need to scoot this thing over. Since I only have 1 decimal place, I only have 1 0 that comes after the 1. So now I'm going to distribute a 10 times every term. 10 times 0.8 gives me 8x. 10 times -5 gives me -50. And 10 times 7 gives you 70. Now, you might be asking yourself, did I really do myself any favors here? Because now I have huge numbers, and you're absolutely right about that. But some people really hate dealing with the decimals. Could you have just added 5 to both sides and then divided by 0.8? Yep, you sure could have. But if the decimal bothers you, you can also get rid of it. So the next step to this would be adding 50. I've got 8x is equal to 120. Divide both sides by 8. And x is equal to 15. And can you check your work? Yep. So 0.8 times 15 minus 5, does that equal 7? So on my calculator, I'm going to type it in. 0.8 times 15. And I get 12. 12 minus 5 is 7. 7 equals 7. That is correct. So I know that's the correct answer. Okay, so this might be a problem that that you would really want to, because it does look pretty messy with all those decimals in there. But you would want to get rid of those decimals. So let's take a look at what's the most number of decimals that we have. I have 2 decimal places here. I've got 2 here. I've got 2 here, and I've only got 1 here. So it looks like I'm going to multiply by everything by a 1 with 2 zeros after it. So multiplying everything by 100 would get rid of all of my decimals. 100 times 0.06 is 6x. 100 times 0.02 is 2. 100 times 0.25 is 25x, and 100 times a negative 1.5 is a negative 150. So now this problem actually looks relatively normal. At least it looks a little bit cleaner. And again, I'm going to take my smaller x and I'm going to move it to my larger x. So that created 0. This I'm bringing straight down. 25x minus 6x is 19x, and I'm bringing this straight down. Now I want to move everything away from the variable, so I'm going to add 150 to both sides to create 0. 2 plus 150 is 152 equals 19x. That created 0. Now I want a 1 in front of that x, so I'm going to divide both sides by 19. And 152 divided by 19 is 8. So now you can test it. So I'm going to put 8 in everywhere that I see x. 0.06 times 8 plus 0.02 equals 0.25 times 8 minus 1.5. So on my calculator, I'm just going to do this whole thing just to verify. So I'm typing in 0.06 times 8 plus 0.02. And I get 0.5. So on the other side, I'm going to type in 0.25 times 8 minus 1.5, and I get 0.5. And so I know that this is the correct answer. Okay, last one. So my recommendation on a problem like this is don't start off by multiplying by 100. Start off by distributing your number, and then we'll get rid of the decimals. So I'm just going to rewrite this. 0.25x plus 0.05 times x is 0.05x plus 0.05 times 3 is 0.15. Yes, I did type that in because I'm telling you, decimals mess with my head too. Promise ya. Okay, so now you can either go ahead and combine your like terms and keep all the decimals in there. I don't really care. But if you want to get rid of the decimals, I would multiply by everything by 100. So multiplying everything by 100, I wind up getting 25x plus 5x plus 15 equals 285. So now I'm going to combine my like terms. And then I'm going to subtract 15. Divide by 30. X is equal to 9. So now, check your work. So I'm just going to type in that entire left side exactly how I see it. 0.25 times 9 plus 0.05 parentheses 9 plus 3, close my parentheses, and I get 2.85, which equals 2.85, so I know that's correct. Okay, so I want you guys to remember that even though I'm not in class with you these few days, I'm not far enough that I can't at least respond to you. So I will be in workshops during the day, but if you send me messages and ask questions, I'll be happy to answer them as soon as I get to them, okay? So just do your homework, keep on practicing, you guys are doing great, and I will see you Thursday.